too far into this. Let me switch over here now. Make sure that this has fully loaded. Yeah, I wound up getting both. Both systems here of mine had to be updated, so we'll make sure everything's good to go. It looks like it's all right. All right, so when the go ahead and load up the software, and let's just for right now, I'll just let's choose open a file, and let's go to our location where we stored our data, which in my case will be in this data sets. Here's something else to let you know as well. If you have your hidden files being visible, you're going to see a bunch of files in your listings here with a period and an underscore starting the file name. You can ignore those, or you can even erase them. You can just select them all and delete them if you'd like. Those are left over from the fact that these files were created on a Macintosh, and then when you download them, it creates those are what are called resource forks. They're of absolutely zero use on a Windows machine, but it tells the Mac OS, some things about the file, sort of like the old INI files used to be on the Windows. So anyway, so let's take a look at let's open up example 1. And we'll go through a couple of things. Now I see that I happen to be in my civil module, because after the points menu, I've got this 3D data menu. So I will switch to survey so that we're all talking the same language. Now, a couple of things I want to talk about are some settings that we need to match just so that we're on the same page here. I'm not going to go through a lot of discussion here, but if you go to the settings menu and choose Carlson configure, and when this dialog comes up, go ahead and choose survey settings. And unless you need the old C&G survey menus to be available, I think by default it comes up in this compact setting. Feel free to set that to none so that that menu goes away. Doesn't hurt to have it, but it's just another complete surveying package that's included as a subset of Carlson, because they bought that company and incorporated everything into it. And that's helpful for people making that transition from the old C&G software, Cowherd and Goodman, right? So, but let's talk about these survey settings real quickly here. The initial traverse / side shot angle mode, if you want it to, if you're typing in traverse shots or side shots, if you're typically always turning an angle right, you might want to set that to be angle right as the initial mode, or you could have it prompt you as to which way you want to run. I'll go ahead and set mine to angle right. And this box right here to show occupy and backsight points on the status bar. I'm not sure, I haven't checked it out with this particular version, but it used to be that this wouldn't work on the IntelliCAD systems. And what that does is it comes down to the status bar down here where in the bottom of my screen where it says ready, and it would say OP : give you a point number, and then BS colon, give you a point number. It's either OP or OC. I don't know if it's occupied. Anyway, occupied point in the backside. So, and all that was done, it just reports as to what is the current occupied point, what's the current backside, so that you know where you are. The reason I don't have mine on, again, like I said before, it used to not work with IntelliCAD, but it's really, once you know the trick, it's really sort of unnecessary, because when you're doing a bunch of coordinate geometry commands, let's say you're typing in a bunch of side shots from some setups and some field books, and then you get interrupted and have to, get up and run out to the field and do something else, or come back in an hour and a half later and you forget where you were. Well, you don't need to worry about that. Or even if you just get a phone call and 10 minutes later you don't remember where you were, because if you do a quick inverse between 2 points, what that has the effect of doing is, let's say if you inverse between 13 and 29, you just say I, enter 13, enter 29, enter, and that has the effect of the first number, it puts you on that point, and then it pushes you to the second number. So first of all, if I go I 13, I'm on 13, and then if I go 29, I jump up to 29, and the previous point I was at is now my backside. So if I need to now start putting in a bunch of points, say sitting on 0.5, backsiding 0.1, I'm just going to do a real quick I 1 to 5, and then start doing my side shots, and then, traverse my way around if I need. So it's just a real quick way to do it. And you can do those inverses at any point in the process, and it doesn't hurt to, do them over and over again. So that could be of some benefit for you if you want to see those numbers on the status bar, if you're using the AutoCAD version, or you can leave it off. Now, this automatic raw file on, automatic line on, and automatic point object snap on has some effect here as well. The raw file is basically the data that you capture, typically from running traverses and side shots, running coordinate geometry commands. And you can think of it sort of in terms of it being your field book. And so if you're going to calculate a bunch of points, and you're going to do it through, putting in a bunch of traverse commands and side shots where you need them, as you enter those commands, it will record them in a raw file, or in that data file. It's the raw data. And you can have it automatically be on, and same as lines, talk about that in just a minute, or you can leave them unchecked, in which case you would have to purposefully turn on those files in the line drawing capability when you go into a coordinate geometry computing session, or some other means that's going to generate traverse data and compute points. So I like to leave mine unchecked and just remember to turn them on when I need them. Otherwise, it's always adding to that raw file. But the important benefit of having the raw file is, let's say you do a bunch of calculations, and some are going to depend on previous calculations, and you're going into like an hour and a half worth of that kind of effort, and then you discover that, oh my gosh, I'm not where I'm supposed to be. I can tell that by looking. So, where did you go wrong? It would be like the difference in adding up a bunch of numbers with an adding machine or a calculator, and you get the total and it's not what you expect. Well, somewhere along the line, you type something incorrectly. It'd be like the difference between using that calculator or adding machine compared to doing it with a spreadsheet. So this raw file works like a spreadsheet, so that you can go back into it, scan through that data that you typed, and hopefully find a mistype or some type of an error And then if you fix that error at that point and rerun that raw file, it will recompute as if you had entered all those computations all over again. So it's a pretty important thing to have and to be aware of. It's just whether or not you want it to automatically come on when you're doing those commands. That's up to you. The automatic line on means that it will draw lines between points when you compute traverse points. If you are traversing, then it sets the foresight point and it draws a line between the occupied point and the foresight. And then the occupied becomes the backsight, the foresight becomes the occupied, and so forth and so on. It will not draw lines up to the side shot points as an automatic thing. Now, the next check, the automatic point object snap, is something that you might want to have on if you use a lot of points. And I'll show you how that works here in just a minute. But then finally, this automatic compare between points that are in your drawing file with points that are in whatever coordinate file you assign. So when you open up the drawing. Right now, this file had no coordinate file associated with it. I look up here in this top stripe. I see that it says CRD none. So there was no coordinate file associated with it, but I do have a bunch of points here. They're in my drawing, but they're not in the coordinate file that I have active right now, which is none. So I would set a coordinate file and I would update that coordinate file from the drawing. So that's how that would work, is that it would automatically compare if you wanted to. But the way I work is I switch in and out of different coordinate files all the time. And sometimes I want to keep points drawn in my drawing that came from a different coordinate file, and then maybe go and work with another set over here or at a different time as my active coordinate file. So I don't necessarily need to keep those on a one-to-one basis, but if that's your style of working, you might want to turn that on so it does that comparison. You can always do it manually after the fact. And then finally, the last button is a land desktop fieldbook codes. And that's sort of a hint at field to finish, but it's from the old, even older days of using land desktop, land development desktop. And that lets you bring in a particular description paired up with a fieldbook code. So for instance, you could say, if your fieldbook code said MH, then your raw description might be spelled out the word MANHOLE, so a manhole versus MH. And that's just, all this works with is just the description of the point and the code in the fieldbook. So we can do that, all of that with field to finish a lot more efficiently. Now, let's talk about this automatic point object snap on or off. So I'm going to go ahead and say okay to this. And I'm going to say exit to that big one. And we'll talk about the automatic point object snapping. If you look on the settings menu, down at the bottom is a place where you can turn that on and off. And if you notice, the little checkbox looks like it's selected in that little icon to the left. That means it is active now. If I choose the command, you see it turns it off. Choose it again, it turns it on. Okay. Now, here's how it works for those of you who may not know. I'm going to turn it off for right now. Now, if I want to draw lines between, say, I'm just zooming in down here. I'm going to go and just draw a 3D polyline from, say, 2019 to 20 to 21 to 22. So if I go to my draw menu and choose a 3D polyline, And I'll just use the current drawing properties is fine. I uncheck prompt for elevation and just say, okay. Now, it wants to know, it says pick a point or point numbers. Now, obviously I could type 2019-2022 and it would work just fine if I had my CRD file open. So that would be what I would typically do is this. Now watch what happens when I do that. It says, well, tell me what coordinate file you want to use because I don't have one open yet. And I don't even know. I don't know what's there. So instead of doing it that way, if I do that same command, 3D polyline, and I want to actually just use these positions and draw those points. Now, down here on my status bar where my entity snaps are, I've got my O snaps running, my object snaps or entity snaps as IntelliCAD calls them. If I right click that icon, something like that, let's see. Uh-oh. What's going on with this? Let's see, fail. Vectorization fail. Wow. Good thing I updated my system, huh? Alrighty. Try that again here real quick. So now my point object snap turned on because I had it in my settings set to automatically come on. I'm going to turn it off just to show you the distinction here. But in my object snap settings, right now you see I've got endpoint turned on. Now I may know that these Carlson points are composed of three things. There's a block of attributes, which are point numbers, elevations, and descriptions. There's a graphic block, which is a symbol, whatever symbol was used to draw that with, in this case, that red X. But there's also an AutoCAD point entity, an actual point that's right there. And you can see it on this screen as a little white dot right in the middle of those cross lines. That would be if I wanted to snap to this, I would turn on this node snap. That's what AutoCAD calls that point as a node. So if I draw my 3D line, and then if I go to the, I'll go here and find that, I'm going to turn this, I'm going to turn my midpoint off. Right, so I'll go here and you can see there's node, and then node, and then node, and then node. Okay, so that has the exact same effect as if I had points and typed in numbers. But if I don't, and I'm going to just go to this and use points in my drawing graphically, I have to make sure that I snap to those nodes. Now, if I select that, and let's repeat that command. And this time, let's say I'm going to just, try my try my best to get to it. So if I click, 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 I may think that I've hit those nodes, but look what happened. See that grip right there? It did not go to the node. It went to the end point of that X, because same thing here, the end point of that X. This one, I was careful enough, same thing with this one. But the reason for that is that in my object snap settings, I had endpoint turned on. So it will find endpoints. And if I'm zoomed out enough to where I can't really differentiate between, what I'm pointing to here, it won't find that node unless I mean, it will if just, by happenstance, but it can also find the endpoints of those symbols. If I uncheck that endpoint, that would work. But, you might be in a hurry a lot of times and not want to stop and change all your settings back and forth. So this point object snap is a Carlson addition to that, the idea of snapping to the point node. It works like this. If I turn it on and then do a command to use those points, I not only, now I'll still, if I'm pointing to the symbol, I still might get those endpoints, but all I have to do is point to any part of the point. For instance, if I just point to, say, that B, or the 5 in the elevation, or the 2 in the point number. So if you point to any part of the point itself, any of those attributes, it will snap to that point node, to that the actual true location of the point. So it's a really helpful snap, and it's basically always using the insertion snap mode when it sees that block, that point block. Okay. So that's a possible useful setting to have. And one more settings to go over. Let's go back to settings menu, Carlson configure. And this time let's look at your general settings. And a couple things to point to here. Is anybody using GIS functionality with your Carlson points?
No, I'm not.
Okay. So you can, in which case, when you record a point, obviously what you're bringing back into the office is a point number, a description, and an elevation, of course, the horizontal location as well. That's just inherently part of its position. So that's really all that you can bring back in. You can assign a symbol and a layer that it goes on, but let's say there's additional data that you could possibly collect, like if you shoot a manhole lid on a sewer manhole, you might want to collect some extra data that would be like, date of last inspection, or manhole type, whether it's storm or sanitary or electric or water, condition, poor, fair, good, or new. All of these different types of additional data, which are called feature attributes, and they can be associated with those points. You can do that in one of basically 3 ways. One is you could, while you're doing the data collection out in the field, you could put that into the point notes for that point. Or if you assigned those feature attributes to that point, or to that point type when you collect it, then it goes into a file with the same name as the coordinate file name, but it has an extension of .gis. And so it's just a linked database that goes, it connects to your CRD file with this GIS file. They have to be in the same directory so that you can use them together, and it will keep that data together. And the same is true of the history file. There's the same file name as the coordinate file .his for history, or I'm sorry, not the history file, but the notes file, .not, and then it pairs those notes with the actual point number or point name. That's the way it has always worked and continues to work if you're using this standard Carlson alphanumeric coordinate file format up here in the upper right block of this dialog. There's a new one now, though, called the Carlson SQ Lite or SQL Lite. That's a true structured query language database. It's based on Microsoft Access file format. And it just has an additional letter in the description, CRDB, which, who knows what the programmers meant that to indicate. But when you do that, it puts those point notes and those GIS fields that you may have defined into that particular point record, and it stores everything all in one file so that you don't have to maintain, 4, 5, 6 different data files for those coordinate points. So if you ever get into using GIS as you collect data, if there's something that's going to enter your workflow, you might want to switch it to that format. It's not going to be of any benefit for us, in these 2 days, but I did want to point out what that was for, and the fact that it's new. And then this object linking is probably the other thing I'd like to have you make sure that you match with mine, so that when any changes might happen, you'll see the same behavior. And over on the left-hand side, where it says use software rendering, yours should be unchecked. Mine is checked because I'm going through an emulator and not through the actual graphic hardware. Everything else could pretty much be however you'd like it to be. But make sure you're using Carlson alphanumeric. That lets you have letters in your point names, point numbers. Turn your linking on and make sure the software rendering is unchecked. Okay. Once that's done, go ahead and hit exit. And that will set that. Now, how do you get these points that we see in our drawing into a coordinate file? Anybody? Let's see. Mark, I'm not going to ask you for the answer here yet, but I'm going to ask you if you know how to do that.
Okay.
So, I mean,
Yeah.
so,
Oh, yeah. Yes.
you know how to do it. So, all right. So Carl and Zoe, anybody, do either of you or both of you know how to get these points into a coordinate file? No? Okay. So what you need to remember is the coordinate file, the CRD file, is separate from your DWG or your drawing file. And that DWG file can have these points in it, because all in the world this thing is really, it's a group. If I select it, I come up here and I see I've got 3 things. And those 3 things are 2 blocks and a point. It's a CAD point. And the two blocks are, one of those blocks is this block of attributes, the point number, elevation, and description. The other block is that symbol. It's just a graphic block. It doesn't have attributes. And then the point, that's that AutoCAD point, in which case right now it's just that little white dot right in the intersection. By the way, that is controlled in your settings menu. Under IntelliCAD settings, if that's the system you're using, and then point style, this is what's called PD mode. And these are the types of display. So I've got a little dot showing. That's because this is sitting here. If I want those points to be, and these are the actual point entity itself, not this drawn symbol. If I want those points to be plus marks, I just choose that. And there you see I've got plus marks. And they happen to be white plus marks. Now, when I select that, it's just a symbol. Or if I just simply draw a point, I just type the point command, just put a point there, put another point there. And you see that's just, it's a point. It's an AutoCAD point, or in this case, IntelliCAD. And if I draw lines between, notice I can't see when I hit that, it finds that node, but it doesn't find the endpoint like it does to this red X down here, this X, because that's an actual drawn graphic with lines. These up here are not created out of drawn lines. They are created from this point style. So that's what that point would look like. I could have the points look like circles and squares and dots. Now that's what my points look like. So if you ever get a drawing in from somebody else maybe that has those set to represent those, and sometimes you'll see them where you'll get pluses. And let's say you'll get things that might look like this. And then when you zoom out, and if it regens, sorry, percentage size. Type a number. There we go. So if you've ever gotten a drawing that looks like that, and then as you, and that's because of that point display size. So you notice as I zoom in, though it's changing, it's always staying that particular size. So, those are fine as long as you understand, what it's going to be doing. So notice as I zoom out, it's always going to be that 5% of the screen. As they get closer, they get smaller and smaller. So that's one of the reasons that Carlson's points give you the options of using symbols. And when you do use a symbol, like if I wanted that to really be a plus mark, I would simply change my Carlson symbol to be a plus mark, but I want it to stay a static size. So I'm going to reset that now back to that dot. And the reason I have it set to the dot is that sometimes uh, some you can have a point. Let's see, or you can have a symbol. Let's draw locate a point. And if I use, that's just for a moment. Anyway, if I use a symbol like a circle or a triangle, then, we understand it's going to be in the center of that, but you won't see anything if you have, say, this selected to show nothing. So I usually put my dots on if I want to see them. And again, you just have to be aware that they're there. But again, sometimes depending on how you draw your plats, I used to have a manager at a company that I was working at years and years ago, that when we drew property corners, we would draw the circles, but then he would have us take the electric eraser to that and make sure we erased everything out of the inside of that circle. He didn't want to see any of those lines come in, or any dots in the middle, that kind of stuff. So, that's your preference, but understand the distinction between these Carlson symbols and the CAD point type of symbol. Now, back to the original question is, how do I get these points into a coordinate file? They're in my drawing, and if I double click one, it's going to ask me to choose a file, because double clicking this, because Carlson knows it's a point block, it needs to go and edit that CRD file information, and it doesn't know what to use. So how do I get these points into a file? Well, the first thing you do is, and that's one way you can do it as a shortcut, is just double click it. It asks you for a file. You can just go to the new tab, give it a name, and you would put that one file or that one point into that coordinate file. So if I call this one just junk and say open, so it's pointing to it there, and it says, all right, there's my point number 2019. There's my northing, easting, and elevation. And there's my description, B-TOE, but maybe I'm going to call this BT. I look at my symbol. I could change the symbol here to something else. Let's make it this circle. There's the notes I was telling you about. So if I had notes, I could put all of that, like date of last inspection, manhole condition, utility type. And this GIS, see this right here, it says requires that CRDB format. That's what I was showing you back in that other setting. So if you choose that format of coordinate file, you can have GIS data editable right here at the point editing. You can associate an image with a point. So if you are setting control and you want to photograph the point so that you can recover the point later, you can take a photo, you hit the add button, and you can have it associated with that. And then these settings, I imagine there's going to be some in the future that it's going to have besides just the number of decimals to show up in the editor, but that's what it is for now. All right, now notice this right here, this drawing description and coordinate file description, because they can be two different things. Right now it says BT and it says B-TOE. So I'm going to say okay, and there it goes. It changed the symbol. I'm going to make that show up like a circle. So if I double click that point now again, it opens the coordinate file and it says, all right, in the coordinate file it says BT, but in the drawing it says B-TOE. Now, that is a little bit of a foreshadowing of how field to finish is going to work. in this particular example, I could have a code in my field to finish code table that says my description is going to be BT. And when you see the word BT in your description, I want you to swap it instead to say B-TOE. That's what that would create, exact same difference. Okay. Now, so I put that point in a coordinate file. I don't want to have to, double click each one of these points and change, but I want to go back to my points. I look up here at the top and I see my coordinate file is set to junk. Right up there it says. And the drawing file says example 1, so they don't have to match. But if I look at points and say list points, and I just list all points, I see I've only got 1 point. The number of points listed is 1. But I want all of these in that point file. So the way to do that is when you have a bunch of these that you want to get into the coordinate file. Go in your points menu, 1 or 2 places. You can go to point utilities and you can update the coordinate file from the drawing. Or you can, instead of the utilities menu here, you could just choose the coordinate file utilities on the menu. And we look at this dialog has 2 columns of buttons, things on the left that work with the files, things at the right that work with points or subsets of points within the drawing or the coordinate file. So right now, I see that same command, update the coordinate file for the drawing. If I say that, it lets me filter out what I want to select. I'll take everything, every description. I'll update the point descriptions, yes or no. And when I do, it will, if I'm going to be overwriting a point in the coordinate file with a new description, it will update that. I'm going to say OK, and now it's wanting me to select entities. Reading the line above that, it says select any Carlson, Land Development Desktop, Softdesk, En-ROADS, Eagle Point, Geodometer, Leica, or Microsurvey points. So you can just draw a window around everything or type the word ALL. Do that. Everything, it found 81 points. It tested 242 entities because remember, each point is a collection of 3 entities. So it found 81 points, and I can list my points. Say, okay, and now I've got all those points. Now remember 2019, where I said I wanted the CRD file to be BT, but because I said update descriptions, it read what was in the drawing and changed it back in the coordinate file. So let's do 2019 one more time, and I'm going to change this to BT. Okay. But it doesn't change here because I didn't change the drawing description, just the coordinate file description. And there it is. So now what happens if you draw point 2019? Here's my default symbol. It's going to go on this particular layer, which is, put it on that layer PNTS. I hit the match and I chose one of the other points. What do I do with duplicates? I'm going to erase and redraw. And I'm going to draw a range, and I'm just going to draw 2019. And it's supposed to have erased and redrawn. Okay, so that now read that description BT out of the coordinate file. But that's what it was previously, was this B-TOE. And you can edit that by double clicking individually, or you can go to points, edit your points. Come down to 2019. Come here, copy this. Paste it there. Save. Exit. Match. Match attributes. Okay, now why has that become giant? Anybody? It's because this actual point size itself, let's take a look. If I measure from here to here, it's 1.41 units tall. And if I measure on this one, it's 70.71 units tall. Now that happens to be because I look at my drawing setup. My symbol font size 0.04. That should be 2 units and not 70. Let's see if I match. Seems to really be behaving on its own. I'm betting yours would probably not do that. Let's see. Well, okay, 20. All right, so that's that. Okay. So now, one last thing about these points and how you can control it. By default, and you may notice in some of your work, you may see these sort of stick figure looking letters, which is it's a really simple vector-based font from the old days of pen plotters, which, you know, it made it a lot easier and faster to draw these particular things. Now, we can make sense of what they are, but you might want it to be a more professional looking font, particularly if you use the elevations or the descriptions as labels in your finished plat or finished drawings. And that comes from a particular text style. And you can look at that under draw text, text or set style. or if you're using the IntelliCAD version, you can go to the layer control, either under the view menu toolbar, and go down to text styles. But that style is called PTX, or yeah, PTXT. It stands for point text. And by default, if you haven't created it and you use a point inside of Carlson, it creates it, and it uses this font called TXT.SHX. Well, you can simply redefine it and make it anything you want it to be. And once you do that, see the O's look like O's, the zeros are different, and it changes for everything. So any questions on any of that? Let's get to go with that. And so now we have points, B-toe and BBBBB. So that's the way that we can use that update to be able to bring points in and out from the drone. So let's say if I'm, bringing in data collector files from my field crews, and every day they bring me a new file of just that day's points. Or I've got my data files that my crews are handing me are named, whatever the party chief's initials are, .crd. So when I load those points into my drawing as I go along, I need to keep these points here, but then I would do, say, draw locate points, and I would use a different coordinate file. So if you'll go ahead and do that with me here, go to points. Let's change to a different coordinate file. Let's set the coordinate file. I've got here a series of points. Let's just go ahead and use man topo. And notice over here, it tells you how many points and stuff that you got. So I've got points 1 through 356. So I'm going to use that one now. And if I draw, or not draw locate, if I list my points, list them all, notice I've got a bunch of points here with some descriptions that are completely different, and point numbers are completely different. So if I'm going to draw locate those points, I'm going to put these on a layer here, maybe change the symbol. Oops, no, that's this set. Instead of X's, let's just use pluses. And I just say draw all. It's going to draw them. And my particular version, for whatever reason, always does that a little bit less than normal speed. Yours would probably be finished long ago, but in which case, what you would find, if you do a zoom extents, it's gone. Wow. The last update might have broken something, but anyway, it's getting there. If you bear with me just a second. All right, so there those points are. Intermingled with these other points that we had to start with. But the points that I have in my coordinate file now are only 10th through 3, 5, 6. These are no longer in their file. So I might want to set to a new coordinate file at this point and call this one, say, junk 2. And then go back to that update CRD file from drawing. I can do it that way and bring everything in, or I could let's look at my coordinate file utilities again. I could remember I had these in junk. I had these in go back, set my coordinate file to Mantopo. So I've got Mantopo, I've got junk. So if I again list those points, yeah, those are those. If I switch to junk, list those. There's my vetoes and B's. Well, I could set this to a junk 2, which should be empty still. Points. So now because I have those points, in fact, I can even delete them from this drawing. I don't even need them in here because they're in outside points. But one of the things, if I wanted to combine those in my coordinate file utilities, I'm going to copy or merge a COD file. So right now my current file is junk 2 that's empty. So I want to import points into this current file. So the point or the file to import, there's my Mantopo, that's these points. I'll say OK. Selection method, take a range, type ALL. I can add, let's say these are all NT-points. Suffix on them, and that's going to add to the name. Let's see. fix rather than right there. MT dash. That's okay. And here's if I want to create a point group. Just go that one MT for topo. And let's merge again, import into the current file. We'll use junk and we'll take all. And this time we'll call it J dash. And these are J points. And that's my points. And I see, here's my file now. Here are my J dash, where they used underscore. That's from junk. And then I had MT, that was from my man topo points. So that created that single file. So one of the things that you might find that useful for is, again, if you're consolidating points into your files from like a daily upload, then that can help you keep track of those. I can also have, because I used a point group when I brought those in, you see I've got these segregated out as groups in which you can do anything that you could with typing a range. You would simply say a point group. Let's say I'm going to use the MT points. Stop with only the MT points. Right. So that's basically it on the points. If you got points in the drawing that don't match the coordinate file, or if you have points in the coordinate file that are either not in the drawing or don't match, maybe you've got some, but they're in different locations, then use those update commands, either right here or from the utilities box, these two down here at the bottom. Okay. Questions? Everybody's good? All right. So we're about halfway through our morning session. I think we'll close this off and take our little break so we can stretch our legs, get another cup of coffee, what have you. So let's take about 10 minutes. We'll come back at 1:45, so at 10:45, and we'll pick up and go from there. We'll put the recording back on now. Let's take a look at the actual survey exercises, where we're going to start looking at some of the survey tools. And before we do that, let's review real quick. I don't need you to load this up. I just want to show you real quickly something about the menus and how they are oriented. Again, these menus: file, edit, view, draw, inquiry, settings, and points. They're common to every module in the Carlson library. They're all the same, exactly in the same place where they go. It's once you get beyond that points menu where you start to pick up the module specific commands. Now, even though points are very specific Turn that back on. So points are very often, quite useful for us in our survey work. Again, it's on, it's in the general set of commands. So when I'm creating points, for instance, I can do this draw or locate points. Draw means read it from the coordinate file and place it in the drawing. Locate means put a point somewhere that I'm going to tell it. So it's basically read and place versus, or also create points. And if I choose that same command, draw locate points, draw range, draw all, draw a group, those buttons are the ones that read from the coordinate file and place them. Enter and assign is where I would actually be prompted for a point number, an X coordinate, a Y coordinate, an elevation, and a description. Screen pick will let me click a point anywhere on the screen, and it could be specific snapped to points, or it could simply be screen picked points. And it will create a new point, put that in the drawing, and put it in the CRD file. And it does it by the settings in this box, like what symbol to use, what layer to put them on, what point number you might want to use, your sizes, various things like that, whether or not to use descriptions and elevations, etc. Now, there's another thing that goes along with this where you see some of these items, like the symbol to use, etc., are preset. But there are some others as well. And that comes from our points menu, very first option, point defaults. And this has to do with, again, there's your symbol.
Down.
Yes. Is that a question?
I think so.
Oh, okay. So these point defaults are also where you would control the, what is preset when you go to create a point. There's that select a symbol. For instance, you might not want the plus mark. You might want to use, say, this X, or you might even be doing some things with inlets and manholes. So you could come up here and set, here's some control points. There's another, 3D utilities, et cetera, et cetera. So there's all kinds of different blocks that you can use. And so we can, let's see, I'm going to choose this X as my symbol. But this layout right here, this attribute layout ID by default is 1. If I choose 2, then my points are going to have the attributes all left justified to the right of the point as a default. I can also come down here and say that I want to use field to finish for the point styles, in which case I have to add to that a coordinate or a field to finish code table. We'll see that later. Which I could do it right straight here as part of my point drawing. I don't even have to go into field to finish to draw the points, but it would choose a specific symbol and place things on specific layers. But just in terms of the points themselves, it will not draw line work. I have to go to field to finish to actually get the line work to draw. So those are all things to do. And again, here's that GIS file. I don't have one associated with this set of points, but if I did, that would be a separate file. I could set it so that it would bring that data along. Again, that's a separate file. If I actually to like that. Okay, so there's the mode. Remember, another one of my settings back in my Carlson configure was this CRDB file. So I could have used that and not needed to set that GIS file in my defaults right here at the bottom. And of course, if I'm not using GIS data with feature attributes, I don't need to worry about it at all. Okay, so we have, again, these menus. And we're going to do a lot of our work is if we have things that are already drawn in our drawing and we need to modify them, we're going to do a lot of stuff under the edit commands. If we need to create things, of course, we're going to look under our draw commands. And these are all typically commands that have Carlson functionality added to them. For instance, if you just want to use a CAD command to draw a polyline, you can do that, P-line, or you could come to draw 2D polyline. You got these extra options here, but the biggest option to any of these Carlson things is, notice the prompt, it says pick a point or point numbers, and that's the big option. So if I went from, say, 25 through 30, what's the points, 25? Oh, I didn't open the let's see, what's my, oh, they say NT underscore, so anyway, this is going to be asking me for point numbers, so I would say NT underscore 25 through NT underscore 30. That should do it. There we go. So that's probably the biggest advantage with the Carlson tools, is that it lets you work with point numbers and point number ranges. Now, I could have created that, again, just polyline snapping to this point object snap on and off, or set my node object snap. I could have typed, or I could have said insert and chosen this block here, created that, or I could have done, see if I had done, it also enter to assign a point. If I turn on, well, it's not really a computation because I don't know if I'm sitting at 25 and needed to set 26. And if I knew what distance 26 was away and what angle, I could do that with these coordinate geometry tools. Again, we'll see some of those a little bit later as well. Right. So whether I draw using standard CAD tools, just draw a bunch of lines, turn them into polylines, close them, doesn't matter at all if what I'm after, because when I draw this stuff, even though I used a Carlson command on that, if I select it and look at my properties, it is still just a polyline. There are no specific or no proprietary objects that are created with this. Okay. All right. So I'm going to close this. And we'll start looking at our raw file processing. We'll talk about what a raw file is and how we use it to calculate results. Right, so we have, as the book tells you here, I'm on page 59 of the manual. Raw file processing commands on the survey menu include both raw data and level data. Raw data meaning the raw observational data, and they typically are things like what point you're sitting on, what point you're backsliding, what angle you turn, what distance you go, what vertical angle, if any, to calculate a new point with that foresight. But there's also level data, and that's basically just your three-wire leveling results. Okay. And that brings up this little separate window. And by default, we're going to use a .rw5 extension, and that's for historic reasons. That was because of the old TDS or tripod data systems that had the first widely popular data collectors out in the field way back in the 80s. But there's others that you could use as well. Is anybody using, say, Trimble or TopCon, out in the field? If you have those raw files, you can bring those in to Carlson directly. You don't have to just create a bunch of text files with points and then bring the points in. So let me ask each of you. Let's see, Mark, what do you guys do? How do you get your points in from the field?
Raw files.
Okay, do you, are you using Serve CE or what?
Yes, serve CE.
Okay, so go ahead.
So I'm new to, so my old company, we would bring everything in by text file.
Right.
So I'm new to the raw file processing. So this is actually a great topic for me.
All right. So in a lot of places, when they bring in with text file inputs, they're really only bringing in the coordinates.
Right.
That what you're seeing. So what you're going to, the difference in what you're bringing in with a raw file is you're bringing in the observations and not the results, not the coordinates. So being that you're using Serve CE, those files are, and you'll actually generate a Carlson CRD file on the data collector that gets computed as that raw file is built and recorded. Okay. And in fact, you could balance that, do the adjustment, do the traverse balancing on the data collector, in which case it will adjust the coordinates on the data collector. And at that point, all you have to do is just copy over the CRD file and open it in Carlson. You don't have to do the raw file processing here in the office if you've already done it on the data collector. Now, most people don't do it on the data collector. Again, it gets into that, the fact that some field crews, and trust me, I'm not throwing off on any of the field crews, but sometimes, the field crews remember their workflows as well. You press the blue button and you hold the shift key down and you hit this arrow key, and that's how you get the data. And if they don't understand, what's going on with the whole concept of balancing a raw file, you don't want to necessarily depend on that as your workflow. So you want to get those raw files into the office so you can process them there. I've got a client or colleague rather that has, he uses this, and I used him a lot for some of my engineering design work. So, I actually have my own consulting practice. I don't just teach Carlson, but so I'll have him do my survey work, and he will bring in a bunch of data over, several weeks. It got to a part that it just, everything looked good in relationship to the other points around it that were observed, but it was like he could figure out, he could look at the resulting points that he was creating, and he could notice where, well, from this point to that point, it's at a completely goofy angle. That point's not right, but everything from that point out forward looks good in relationship to those points, and everything from these points backward look good in relationship to each other. It's just the other points wrong. So what basically happened in that case was that he forgot to zero the plates on one particular backside. He picked up and moved ahead, and he never zeroed out his plates. So those angles weren't, they were, in addition to the angle he actually measured in space, he had the circle reading that was left over from last time. So, pretty straightforward fix. We go to the raw file, we just edit that spot where the plates weren't zeroed, and insert that zero angle record, and that reset everything from that point forward. So, all of his work was still fine. He did not have to go back and do any of the other work. We just had to find that place that it was. So that's the advantage of doing that. Now, if you're using GPS, you got a bunch of rover shots and you got a base station going, your raw file is going to look completely different than what you would see using the total station, because they're not traversing. They're not, I guess they're technically using side shots, but so what you will capture in that raw file are actual, satellite vectors and timings and such. And so that can be used in your processing of these files as well. They have certain things. Once it reads that data and knows what it is, it can apply basically averaging if you've got multiple multiple saves from that point of occupation when you're sitting on a point. So it's really good information to have that you can always go back, and that's your audit trail that you can look at, review, change if you need to, or at least find where things might have gone wrong. Okay. So here, if you look again on the page 59 in the manual, you'll see that little discussion where we talked about, why do you bother to adjust them? Aren't they close enough? And in fairness, sometimes they are. And if you are building a fence to keep cattle in on a farm, and you've computed your points or whatever, balancing that traverse to tweak a couple of hundredths on your fence post locations, is it necessary? Not really, because you can put a fence post down within the the center of the hole that you drill in the ground. So, using a little common sense as we go around, but this talks about, what happens if you don't adjust. So if you don't adjust the measurement, you're not averaging or evenly distributing that accumulation of errors. throughout the whole network, you're throwing all of the corrections into the very last observation. So, that's what this discussion is in this section here. So I'll leave that to your own your cognizance, if you will. Now, here are some methods. So the typical workflow in doing this type of adjustment is that you typically would first apply an angular adjustment. And then once those angles are adjusted, you would go through and adjust the coordinate positions based on the results given to you from the compass rule or the transit rule or the random rule. Compass rule is the most commonly used. And that's a compass rule adjustment is really nothing more than a least squares adjustment, but with all of the observations having an equal weighting factor of 1. Right, so what it tends to do is it takes I guess in a very simplified fashion, it takes the amount of misclosure at the end of the traverse, but both angular and by distance, where it takes the angular misclosure, divides that by the number of angles in the figure, in the traverse, applies that amount of adjustment rather to each angle, or not the disclosure. It takes the misclosure and divides it by the number of angles to get how much per each angle that it would have to adjust it. Adjust the angles, and then does the same things for the distance, and it will apply that on an even basis. The same ratio, the same amount of correction gets done to each leg or each angle. Whereas least squares is a methodology that does that same type of thing, but it looks at the relative strengths of each of those observations, and you as an observer need to either somehow document those in case, maybe 1 or 2 measurements might be a little iffier or less stringent than some of the others. So they might have a higher weighting so that it gets more of a correction applied to it than, say, to some of the other ones. But the whole thing is done so that when it computes the points, the final adjusted points, the new positions have been placed where the difference in the new position and the original raw position, that differential, and it looks at all of those differentials in the whole network together, and it finds that adjustment such that all of those differentials have been minimized. So it applies a bunch of rules, it takes a look at a bunch of things, and it has, and it's actually, it's minimized the square of those residual distances, which is why they call that a least squares adjustment. So that's, really, it's a really rigorous adjustment. And see, it says right here that the least squares criteria is reached from the sum of the squares of the residuals, or the individual spreads of each measurement once it's been minimized. Okay. So we'll look at a couple of things there. We'll have to take a look at those raw files when we get to them. But so what we're going to do is look at this in a fairly simplified fashion, and then we'll look at some more complex numbers here. So give me a real quick moment here. I gotta reply to. Okay, one quick second. Let's see. Okay, sorry about that. Now, all right, so we're going to use these RW5 files. And like I said, you can think of that as this electronic version of your traditional field book. And it also records coordinate geometry commands. So we're going to start a new drawing and we're going to set a new coordinate file to use with it. So we're going to come over here and choose a new drawing. And I will choose one of my templates here. And when this comes up, I will go to the set button and give it a name. I'm going to make sure I am in the same folder that I have my data files in. Right now, it just starts me off up here at Carlson project. So I'm going to make sure I'm down here in my survey class, materials, data sets, and I'm going to call this one raw file example. Okay. And let's set our horizontal scale to 1 inch equals 50 feet. I'll make my symbols 1/10 of an inch, and I'll keep my text down to 8/100 of an inch. And I do not think that is on a particular coordinate system, any kind of state plane. So I'll just leave it set to none, or yeah, like that. And I'll say next. Now I see my data path is set correctly. My coordinate file uses the same name as the drawing. I'm going to say that it is a new coordinate file, and I'm not going to bring these points in by a data collector or a text file, or bringing in from an existing CRD file. So I'll leave it to set to none, and I'll say next. So there I am. I've got a blank drawing. I can even go to my settings and that's what I want there. There you go. I've gone ahead and created a text style called PTXT, so I don't get those ugly fonts for my text. It's up to you if you want to do it. No big deal. What I would typically do is have that. If I had a particular one I wanted to use, I would define that and keep that in my drawing template that starts when I start the system up. Okay. So from here now, we're going to choose process raw file, and we're going to open, or we're going to, let's see, create. Well, let's go ahead and open this raw file 1. But you can create these if you wish. But let's go to survey menu. We'll edit process raw data. And this little subsystem is going to come up, and I'm going to choose, it has a set of menus inside it, a set of icons that basically do the same thing as these menu commands. So I'm going to file, open a raw file. And I'm going to find this raw file 1.rw5. And it should look like this. Now, yours might not look like that on the screen. Yours might look like, let's see. Yeah, it may look like that, in which case that's the graphics on and off. It's controlled by the display menu, graphics pull right. Okay, so that's going to be what we see in our data file. Now, we've got several things going on here. I've got a little traverse that I see, and I see some point numbers. If I zoom in down here, oops, we go to so if I zoom in here, I can see that I've got a double here. It looks like a 1 and a 5, which it is. 2, 3, 4, 5. So I started at 1. I've got a 0.99 over here. So I set up at 1, backslided 99. I turned around to 2. I moved up to 2, backslided 1. I turned to 3. I moved up to 3, backslided 2. I turned to 4. 4 to 5. 5 being the same as 0.1. That's my check-in to come back where I started. Now, I'm not a big fan of traversing in that regard. And there's a reason for that. I'll show you that what that is in just a little bit. But for the exercise, we're going to keep it simple. Now, what we have above here now is a series of records that show what we've observed. And notice if you click on these lines up here above, you'll see down in the graphics business, these things highlight themselves. And if you don't see this graphics, choose this icon, the pencil, that says graphics on or off, or go to display menu, graphics on. So now, in this very simplex version, we're saying right here, I'm going to store a point. The old 5,000, 5,000, elevation 100 is called control 1. So that record is a PT record. See, I can pull this list down and choose from a number of different records, some of which have Gs, those are GPS commands. I can also see those same things under add. So if I add a side shot, or if I add a new point to store another point, I can import from another file, use a command to calculate a point. I can add a traverse point, a side shot point, a backside, etc., etc. All of the things that your instrument will record for you, and you'll see them there directly. So we've got this one in here, again, really simple. So I stored this point. Notice these headings: point number 1, northing 5,000, easting 5,000, elevation 100, description C2RL-1. And down below, I've got a backslide record where I say that I'm going to occupy point 1, that's my 5,000, 5,000, and I'm going to set that at an azimuth of 270 or due west. So that's why I'm setting up my backside. Maybe that's a church steeple. I don't. If I had a particular point already computed, I could use the point. That would be no problem. But I don't. I'm just going to say, set that That's where it is in the world. Then I'm going to go from that setup. I'm going to run a series of traverse computations. Again, I'm sitting on occupy point 1. I have a foresight point of 2. Notice these blue lines here. These are header lines, and they change based on this column on the far left as to what type of observation it is. And you can actually turn off these record headers. So hide record headers. So if you don't want to see those, you can turn them off, but you have to know what they mean. So I will show the headers. All right, so there it is. 1, looking at 2, angle right. So I turn an angle right of 180 degrees and I go 100 feet. So 1, looking to 2, but I am backsliding that original backslide that I've got created up here, set to 270 degrees. And I turn 180 degrees and go 100 feet. I now, because that's a traverse command, I'm now sitting on my foresight point, which is 2. And the backslide point is automatically shuffled up or pulled up, from where it used to be out here. It's now going to be the previous occupied point. So 2 is backsliding 1 and setting 0.3. Turns an angle right of 270 this time, because I'm sitting at 2, looking at 1, turn 270, go 100 feet, and there's my next point, number 3. Because I'm traverse, I'm going to move up to 3. I'm now looking at 2. I'm going to set, again, point number 4, which will be this point here. So I'm turning an angle of 269, 59, 58. Obviously, this data is contrived. I've put in the error in this particular spot. And I'm going this particular distance to create point number 4. Again, traversing, I move up to 4. And I'm setting 5, but I'm backsliding 3. So I turn this angle now, I'm back to 270, 100. And notice this little key right here, equals 1. I'll show you that in a minute, what that means. That's basically telling me that it should equal the same as 1. And then I'm going to move up to 0.5, and I'm going to create this foresight point. Again, which could be that church steeple or whatever I backslided originally. And I'm going to turn an angle right. In this case, it should be close to 90. Well, I declared it 90. I went 500 feet. And that's my closing angle, or what's called an AB, which is an angle balance shot. 4 to 5 was a CL, which means closing distance. Now, if you are the type of surveyor that closes your traverses without an external backside to them, you can combine that last elevation as a closing distance and angle balance shot, so it would know how to do that computation. Right now, this is going to be fitting your data. So we already know just by inspection, we're going to have some errors here. So we're going to take a look at the processing that it's going to do. We have a coordinate file established called raw file example. We haven't created any points in it yet, but once we process this raw file, it's going to create 0.1, and then 0.2, 3, 4, 5, and 99. And so what do we have in our system here? We've got some file, open, new, save. You can import all of these different brands. You can also export, run reports, raw data, coordinates, summaries, etc. Then on these edits, pretty much like spreadsheet edits, cut, copy, paste, delete rows, modify measurements, but it's all very graphically able to just click in and out of the cells and make those edits for you. Display decides what it is you're going to see and how you're going to see it. Spreadsheet colors lets you assign like traverse, side shot, sets. If you're, running multiple angle observations, IR, or the HI and HR, backslide to purple. So that's what you see these codes right here for. And it's just a way to sort of keep track. Don't have to use that at all. And let's see what else do we have here. You can even track changes just like a word processor and go back and undo those. This add business is where you're going to add records. And again, they can be, traverse, such a, all of these different things. You can read that as well as I can read it to you. And then we're going to look at some of our tools here. So we typically would go through this no adjust just to see what the raw computational values of these points are. Okay. And then we might apply an angle balance and then apply a compass rule adjustment or Crandall, transit, least squares. Now these are like a transit rule adjustment is an adjustment that works best on data that is collected with instruments that have much greater accuracy in the angles than it does in the distances. Hence it's termed transit. So back in the day, I might, go out there and measure all my angles with transits, but I'm going to measure my distances with tapes. So, I would trust my trusty dusty old K&E transit more than I would trust my ability to pull steel tape between points and keep things level and all of that. So in Crandall rule, there's I forget what its optimization is, but the compass rule tends to give equal weight to the angles and distances, and it really started to becoming the de facto one to use once total stations were developed so that everything is measured electronically, the distances as well as the angles. So, or, even prior to that, if you measure your angles with a theodolite, which is more accurate, obviously, than a transit, and then maybe even if you took that off the tripod, but immediately set up an electronic distance meter, which we used to do separately like that. And, but because of the higher precision of those instrumentation choices, it would give equal weighting to the adjustments. Okay, so nothing to really have to remember other than just figure out what is going to be your best means. Now, least squares, which is not going to be real useful on this particular one, but you would, because there's a lot of setup that you have to go into providing, like you have to know the the pointing error of the crosshairs on an individual instrument, or the distance repeatability errors. So you put in a bunch of sensitivity values, if you will, and it compares the measurements against those and uses that to help in the residual calculation. And there's two types. There is the one you see here, which was Carlson's least squares adjustment that works on a single network of observations. What most surveyors really did that were really meticulous about this is they may run this little traverse here for this project, but then they're going to tie it into another network of adjusted points, or maybe even another network of raw observations on another project, just as a check and balance, between those two. And then that becomes a multiple network traverse where you've got, things that just share common points, and you tie one of those networks into the other networks with common observations. And that was something that Carlson had not developed yet, but the guys over at C&G Software had. In fact, they had a program that they developed called, let's see if I remember, what was it called? StarNet, I believe. And that was really all that it did. And some surveyors would buy that program just to get that adjustment. And in fact, Carlson looked at the opportunity of saying, well, you know what? They really did a good job. Everybody uses that. So why don't I just buy the company? So he did. And he purchased that entire competitor's company and software development capability just to get the multi-network GPS adjustment. Now, and then the rest of the Stadia GPS are some different, Stadia, it's a different, that sets up rod intercept, level rod reading intercept, which will compute a Stadia distance, tell you how far out you are. So you're not really measuring distances, you're measuring between the crosshairs on a graduated rod to be able to calculate. So then, sort of kind of esoteric type of things. But what I want to show you with this least squares idea, this, like I said, is the one that we have in Carlson. But we have another one that I don't know that it's, yeah, so I'm going to do that yet. So just keep yours right there. I'm going to save mine. And I'm going to close this for just a second. And that was our edit process raw data. But now here it is, this ServNet least squares. And that brings up, let's bring up this project. I will find the raw file. Yeah, it's right there. All right, so this brings up this entire system with its own set of settings where you put in all of these different, pre-processing, standard errors, adjustments, output options. So it's really complex, but it lets you do that entire network adjustment. So it's not, it's not necessarily, something that you can do just right off the bat. It takes a little setup, but once it's set up, it's set up. You don't have to keep doing it. So it's really the most robust means of adjustment, and it will even, allow you to tie one network into another network. And let's see if I can. Matrix. I was hoping I could show you that. Picture. Well, let's come back to it. We have some time. I don't. There's again, it's an entire college course on doing least squares adjustments, but I don't want to get into taking up too much time for that. But the point that I'm making here is that if you look at the raw file, edit process raw data, it has the least squares adjustment command in it, but it is only for a single network. Whereas this one, ServNet least squares, is the more robust one. Okay. All right. So now I'm going to go back to survey, edit process raw file. I'm going to open my raw file one. So we're back to this. All right. Now, under process, let's see what else we've got over here. Let's look under file, open save settings. Yeah. Starting on the file menu, if you choose open/save settings, there's a couple of things you have here. You've got these open settings up here. You've got save settings down here, which will automatically save the coordinate file if you want it to. Otherwise, it will prompt you to do so, which is what I like to keep mine for. I can also have it prompt me for a raw file as soon as I start up. It did not. Yours may have, in which case you would see that it should be checked. So I had to go and purposefully open the file. And then finally, I've got these terms here that if I want to have it automatically recognize that it has a closing distance shot or an angle balance shot, I need to put in my description in my data collector, whatever I want to use. Let's say if I want that closing shot to be CS or CLOSE, I would set it to that. And if I want my angle balance, I can make it AB or A and G, yeah, whatever I choose. So then when I read all of this stuff in, when I'm in the field recording that description, if I put those descriptions in, it's going to know to automatically make the record of type CL or AB. So again, I'm not really going to be using that on this particular file, but just some things to say. Now on the process menu, look at your process settings. Here's where you've got a bunch of things that are going to help you flag errors and that sort of stuff. So if I look at my distance tolerance, horizontal, 500ths, vertical, 500ths. So this means if you are turning multiple sets of observations to a particular point, and if they disagree with the other observations to that same point by more than this amount, flag as an error. And again, those would be those residuals, those differences. And then if I'm going to average these observations, what is it that I want to average? If I can either average the distances and then compute, or I can or if I say that I want to average my coordinates, what I would do is I would not average this once and compute it once. I would compute it, 4 times, however many sets, however many observations I have in each set, and then average the coordinate once that was done. Okay, so just a slightly different means of how you want to process it. Now, next one down is to override the backside azimuth when you have a backside coordinate file, meaning you so the backside coordinate file. Basically, it's going to apply the computed azimuth to that backside point if you're using a point from a coordinate file and not like we are here with just an observation on a specific angle. And then if I report checkpoints, again, remember this trav5 equals 1 up here in our file, that's my checkpoint. And the checkpoint code, right there's what makes it a checkpoint, is the fact that I put an equals there as the code I'm looking for. So it comes up here and says trav5 equals 1. So it knows what it's supposed to equal. And again, I've got horizontal and vertical difference or distance tolerances that I can allow. So if I come back to that trav5 equals 1, and if I don't compute within that distance, it's going to issue a warning. Okay. And then where do you want to store the points? Either when you have an empty coordinate file, or you don't want to store the points, or in my case, I added it as always, because it's always going to update that coordinate file, and then I can, apply different adjustments, anything else that I may have found. It will take care of that for me. And then I report the store points, and that's this record up here, number 2, where I've stored the coordinate values. It's going to report that for me. And I'm going to say hold the store points. So if I had set a bunch of points, or I'm sorry, stored some points here, and if I calculate that same point by observing it instead of storing it, I can use that to calculate differences. But if I say hold the store points, then don't adjust that point, hold whatever I type in and make the adjustments on the ones that are not stored values. And there's an option then to convert occupied records to store point records. Not sure why you would ever really need to do that. Depends probably on the different data collectors. And then angle only measurements. If you're talking about the angles, and this is where sometimes you would do an angle balance first before you compute the rest of the traverse. Then how do you want to choose the elevation based on those angles? It can either be the lowest of the set, the highest of the set, or choose an average. So that'll give me, assuming I've got, relatively consistent pointing ability, and that will be the best approach. On the right-hand side, instrument and rod height ranges is you would typically set, say, maybe at 4 feet to 7.5 feet. Yeah, that'd be like 27.5 feet for this one. Let's not make it points, so. Not that that matters. Because what these are doing here, you don't need the decimals, I'm just putting them on there, but what you were looking at is anytime it reads a record that sets the instrument height or the rod height, if that value is not within those particular ranges, again, throw up a flag and let you look at it and fix it if you need to. And that's what happens in the case of if you forget to record the measured value from out in the field. Now, you don't necessarily know what it was, but let's say you did and you just missed it, or if you mistyped it at the time you're recording it, this gives you a way to look at it and say, oh, I got to fix that. It wasn't 120 feet, it was 12 feet. Okay. Direct reverse settings is you can balance them or choose direct only. And then your foresight backsight, you can balance those or choose foresight only. And again, now we're talking about angular tolerances instead of what was before, these distance tolerances. So these are the how tight does your equipment measure your angles? Is it a 20-second gun? Is it a 5-second gun? Is it a 1-second theodolite? Whatever those values are. And again, the distance tolerance, 2.5 hundredths for that. And when I take measurements to control points, do I want to store those to this coordinate file? Because I can have a separate file for control points. So if I compute to a control point with a known coordinate, often it's other separate file, I'm going to get a slightly different number, but I'm going to store that in this current file just so I have that point. And then finally drawing the points in the line works. Do I want to draw by field to finish? Yes or no? I'm going to say off for now. And we'll say okay. Now, I'll say okay to that. So I've finished. What's going on? Right. Send process settings. Didn't dismiss. All right. So now, if I look at my tools menu real quick, here's where that coordinate control coordinates were. Is you can set a separate coordinate file of control points. And if you make observations to those stations, just for checking, for instance, that's what that switch was for you to store it into your local raw file or not. And you got point groups. You can generate groups based on traversing, side shots, or all groups, etc. So if you wanted to, let's say you got hundreds and maybe thousands of points, the ones that are traverse records, you could have it automatically put those points in a group called traverse points. Same thing for side shots, or do them all. Just a means of tabulating or cataloging your data. Okay. All right. So now we've got that part done. Let's do our first pass of no adjust. So what this is going to do is read everything, and it's going to compute in compute the raw numbers and take a look at that and see. One quick second here. Sorry, I'm still having to answer my client here. Let me get back to that, find it. All right, so in my process options, I did no bounds. If I had multiple measurements to the same point, how do I want to handle it? You can read your choices. I'm going to take the average using backside reciprocals. I want to average my elevation and distance or average the elevations only. I'll take them both. Resize this a little bit. There we go. All right, now. And whether or not I want to calculate elevation. So if you're not doing or needing your elevations for those traverse points necessarily, you could say side shots only. Calculate the elevations only for your side shots, or turn them all off, or turn them all on. I'm one that likes to calculate the elevations, even if it's a traverse point, because you never know when you can use it. So it's there. Some other various switches, point protect, meaning if you already have that point in your coordinate file and you're trying to create it again, it's going to throw up a little flag. So that's why I turn it off here, because I'm going to be running these multiple times. I don't need to have it bugging me every time it tries to do it. Creating point notes. And if you had place this on a state plane coordinate system grid, then you could have it calculate a combined scale factor for each measurement. Otherwise, it does it for the overall total site. Or you can do it as if you have a number that you've computed in the past in that area, you can generate that as well. And whether or not to correct for earth curvature. Again, on this little thing, we don't need that. If you're running pipelines, from one state, 2 states over in the oil and gas industry, earth curvature actually does come into play. Our report options, custom, tabular, or standard. Let's just keep that as standard. Report angle format, whatever the raw file format is, that's what that's for. Number of decimal places, I'll go ahead and put 4 places. I'm going to report my closure if I know what that one is. So this would be point number, my reference closing point is going to be point number 1. So I'm going to come around here to 4, now 5, so it knows what it's trying to hit. Right, so if I say that and choose OK, it goes, well, tell me what your points are. Tell me what your traversing is. And it's notice it says to specify your traverse points from start to end, either automatic or prompt. Automatic means it's going to read these values up here where it says TR and figure out which ones it needs to use. That's automatic. If you say prompt and OK, you're going to get this. And you can add, see 1 through 4 to 5. So see, it found them successfully. Let's say if you didn't want 5, you could remove that out. So that traverse would go to there. But whoops, I didn't match your point. Let's come back. No adjust. Just leave it as automatic. So sometimes you may even have traverse type records. Let's say I went from 1 to 2 to 3 to 4, and then I shot off a little fly traverse over here, but then came back and went to You know, over here I went 5, 6, 7, 8, and I just left it hanging, but then I came up here and then went 9, 10, 11. Well, I may want to omit these points over here as part of my traverse, and only the part that actually forms that closed circuit do I want that to be considered as adjustable points. Okay. So I will say, okay. And it says, what here? Error 3, no coordinates stored for occupied point 1. Other than what happened? Okay, editor. I should have done that. No adjust. Marriage. Oh, let's uncheck this report closure for right now. It needs to have something already computed. For right now, I don't have that point. So if I say okay now, nope, still tells me no coordinates stored. So once again, I think I had actually processed it. Let's see. Let's calculate average all. Right, so okay. All right, so occupied point on is try this for a minute. Well, this is new. It's not recognizing this. All right, that should be what I need. Oh. Something has completely reset. All right, save. Store point records. Height. Four. Now, there we go. So I don't know what caused that to reset, but it was because of, let me exit this. It was, this had been all reset back to zeros, and it did not have this store point records the coordinate file. So now it's done it. So now if I do no adjust, so I'm just going to compute. Let's see, let's do my report closure, 5,000, 5,000, 0.1. I'll say okay to that. Now, here's what we got. This is the first pass through the data. I've got closure results. So I'm starting with my 5,000, 5,100. I am closing back to itself at 5,000, 5,100. That's my closing point, which again, I'm not a big fan of that process. I'll show you that again in a minute. My ending point now, point number 5, is actually computed as 4999.999 to 5,000.019 elevation 100. So I've got an error azimuth, which is the distance or the direction rather that the misclosure is at 0.5 to 1. And this is how much I'm off in the northing and how much I'm off in the easting. I had no vertical error, no misclosure there. And comparing horizontal versus slope distance errors, then they should be the same. And you see that they are. Okay, and that's basically the resultant of this. Okay, so basically 2/100ths. And I had 4 traverse lines, 1 side shot, 1 store point. The total distance traversed 399.98. It should have been 400, but because I did no adjustment, everything's done here, and I look at this, and I see that I have 1 in 20,000 or 21,000, 1 part in 21,000 of error. So, and down here's my raw data that you can see. There's 5 equals 1. There's the stored point. Here's my checkpoint at a reference of 1. I measured to 5, and there's my delta. There's its computed difference, 0.0191, which is this number rounded. And HR vertical angle. So this is the observation. It's line 1, occupied 0.4, slope distance of 100, horizontal angle of 270, a zenith angle of 90, an HI of 0 and HR of 0 to calculate that. So there it is, just raw. You may look at that and say, well, okay, that's pretty good, although we know where it is. So there it is with no adjust. That's just a raw computation. If I were to get out of this, save my coordinates, that would be what would come to me when I took a text file out of my data collector and brought it in. Okay. So we're going to apply an angle balance first. So we're only going to consider these angular measurements and apply the angle balance first. Take multiple measurements, to the same point. Again, it's the same dialog we had before, so we'll leave those as it was. Reporting the side shots, any unadjusted points. My reference closing point, again, is point number 1. So, okay. 1 to 5, automatic, okay. And now, so what is my reference closing angle? So the angle, because I'm doing an angle balance here, the reference closing angle is going to be 4. Closing point 5 to 99. So 1 point. Let's see. So there it tells me right there, my angular error is 2 seconds, which I can see up here was at 269, 59, 58. But it should be. Oh, no, okay, sorry about that. So I should be from 5 to 99. What it should be is, so I'm 5, backsliding 4, I turn to 99, so it should be 90. I think that's right. If I say okay, now I see that here it is, my closure before the angle balance. That's the same thing we saw before, 1 part 21,000. And here's all that data. Now there's the side shot, that last 99. My closing angle, and here's my checkpoints. And now here's when I apply the angle balance. So I've got 179 degrees, 59 minutes, 58 seconds for 5. Traverse, oh, I've not done this correct. It should only be 2 seconds for 5 sides. All right, so what did I miss? Angle balance, all of that, reference closing point. Okay. So now from my point number 4 to 1 to 70. Yeah, there we go. All right. It really should have been. I'll have to look at that. I'm not sure why that came in like that, but here's our original like we had before. And now when we look at our angle balance, we're seeing 2 seconds of error to split among 5 sides of the traverse. And that's the 1, 2, 3, 4, and then closing back to 99. So I need to adjust each angle by 4/10 of a second. So here now is my closure after the angle balance, which is going to be one part in 2588.9. Now, you might be tempted because that number 2589 is less than 2991. You might decide, well, I'm not going to do an angle balance. I'm going to adjust without the angle balance. But the proper means of computing this is to balance the angles first. And even if it gives you that lower number, you still use those balanced angles to then go and do your distance adjustment to compute the final coordinates. Okay, now, a couple of things to talk about here, and then I know we're into lunch here. I'm going to give you your full hour, don't worry. But I wanted to finish up to this point. So when we have a figure like this, and we have all of our error is in this particular point, in that observation. If that were 270 and 100, of course, it would compute flat. So what we've done with this adjustment routine is we have assumed that the angles or the angles and distance, all the observations, I mean to say, in this set of measurements is about as close as we can get it. And the source of error in this is entirely say random, but it is not systematic errors. It's not like the instrument is always reading 2/100ths of a foot too far because it's out of calibration. That would be an example of a systematic error. So this is a case where we're saying that, we're expecting that every observation is made with the same relative care, and therefore whatever errors accumulate in it, we need to distribute through all of the observations. And that's going to be most of our situations. But in this particular case, we have this as our error. And when we look at that misclosure here, there's a couple of tricks that we can use that will find a particular observational error. And I wish we were in a classroom. I could show you this on a whiteboard a lot faster than I can try to draw this. But what happens is this point out here, point number 5, and let's see if I can't. Okay. See, point number 5 here is you can see it. There we go. See if I can get there. Well, All right, can everybody see? Let me see. Oh, for heaven's sake. They just. All right, let's try that now. All right, so everybody can see that difference, 0.5 compared to 0.1. So if you recall where we were at 0.4, and 0.4 is the one that actually got computed in the wrong spot, because sitting on 0.3, we did not turn a big enough angle, and we did not go as far enough of a distance. So what happens, if you can keep this part in mind, I'm going to need to go back to this. So what happens when you have what's called a blunder, where one of your errors is in one particular observation, when you look at those numbers, like this on a no adjust, this right here, let's see, the azimuth of the error is 92, 54, 58. So that means that the amount of misclosure from 5 to 1 is at 92. Well, it's actually opposite. It's 92, 54, 58. So it's a little bit, it's 90 degrees, which is like 3 o'clock on the clock dial. And then a little bit more, just, 2 degrees, almost 3 degrees more. But it's only this distance. Right? So when you have numbers like that to look at, to find a blunder is when you, if you were to look at that, remember that 1 and then 5 was down and to the right. So I would try to find the error of that angle, the distance, is that nearly horizontal. So it tends to be that the error itself, if it is in one particular observation, like a particular distance, you would look at sides of your traverse that are parallel to that misclosing line. So it would be that are most closely parallel. So it would be either this one up here or this one down here, because that was nearly horizontal, but it's just slightly two. 2 degrees or 3 degrees rotational. If it is an angular blunder, in which case we got them both, then you would take that line, and which, remember, it went like this, okay, and then well, it's not showing up. It's because I've got it, so it's not really. And I'll tell you what to do. Let's see. Put this in here. So see what I did is I just change that distance to 100. So my distances are all the same. So now here's my error. I'm going to now say no adjust one. Wow, see that made quite a difference. That's sufficient for most places I'm going to look at. But here's what I'm getting at is if the error, this 224, 59, 59. So 224, if I think of that on a XY axis, so 180, then 224, that's 270, then 224 is going to be pointing like this. So if it is an angular miss, which in this case it is entirely angular, and I don't think I can zoom in to that enough to get out on that time. Anyway, it's below along that. So if you can imagine a line that goes like this, that's how much that's what the error is. That's what the misclosure is. So if you're looking for a blunder in angle values, you want to construct a line that is perpendicular to that closing line. So it'd be this way. And then you want to look at your traverse figure and find the angle or angles that most closely would be bisected by that perpendicular line. And you can look at it just by inspection. You know, we underturned to get to this point. So we said here to here to here, and then instead of turning all the way around where it needed to be, we turned short. And that's what, and then we were good the rest of the way out. So that difference right there is caused by this difference in this angle not being big enough, you know, around this way. So it really needed to close up. This angle needed to be smaller by that, whatever that number is that computes it exactly to it. So angles are found by perpendicular constructs through those lines that would point to the bisector of the shape's angle. If it were distance instead of this, let's say it's 270, and this was the original 99.98. No adjust. As a reference, say okay, say okay. And now you see it's a little bit less than it was that last time, but my error is exactly 90 degrees. And I've got a difference only in the east direction, none in the north. And it's that 2/100th. Okay. So now I'm going to look at parts of my traverse that are parallel to that. So I had that 90-degree misclosure. So I'm going to look for I'm going to examine all of the legs of my traverse that are perpendicular or parallel to that instead of perpendicular to, and find the angle. And that would help me find that as a blunder. Okay. But now it doesn't help you if the error is both in the angle and in the distance, like it was. So we can also try under our tools, find a bad angle. Now we don't have a bad angle. So let's put this one back to 269, 59, 58, I think it was. Whoops. 58. Just one, go, exit. And now let's try to find the bad angle. My reference closing point is 1. Let's say okay. And okay for that. Now the reference closing angle. So, there it is. So 5. Yeah, back to 1. All right, so now, okay. And so here's where it thinks it is. There's my stored points. Here's my reference, what it should close back to. Here's what it measured. Here's my difference. And find a bad angle. It's, well, you've got 2 seconds for 4 sides, and the bad angle is at setup 2, which is the foresight to point number 3. So that would be this one. Okay, so you see this being angles and distance are both bad. It's not going to find it. And it's using that same technique I was showing you about, that perpendicular and previous. So if I have 100 now in process, pretty tight there, but I've got a bad angle. And now if I find the bad angle, it says bad angle is at setup 3, foresight 4. Okay, so it finds where it is based on the expected calculated values around the figure and closing the horizon here. Okay, so they don't have a find bad distance tool, but if you remember those particular things that I was telling you about, the misclosing line, go perpendicular to it and look for the angle that that perpendicular line bisects, and then go parallel to it and examine the sides of the traverse that are nearly parallel to that. Okay. And that's how you find blunders. Now, when it's a case of both, you won't be able to use those tools because your error is coming from 2 different locations. Okay. I'm going to save that raw file, and we'll come back and look at the compass rule adjustment when we get back from lunch. So it's now 12:35. I'm going to give you your full hour, of course, so we will see you back here at 1:35. And any questions before we go? Resume the recording, and we'll finish up the last little bit of the application here is we're back to the original data set. And so if we look at our angle balance again, and our closing angle, let's see if I can get this to It should be. So 5 to 99 should be. Should be. So it's 5 to 99. A reference closing angle. There we go. It's not, yeah, right there, not the angle balance, but the closing angle. 4 to 5 closed it up. And it should have been 270. All right, there we go. So then our angle balance took 2 seconds for 5 traverse sides. Applied it to 4 angles. And set our adjusted coordinates now. Based on balancing the angles here with the angle balance, then computing this amount results in this closure. And now over here on these 2 columns, you'll see the adjusted coordinates for, what should be nominally 5,000, 5,100, 4,900, 5,100. So you can see how it's tweaked those coordinates based on just resolving the angles. Okay. So then next we would perform our compass rule adjustment, and our reference closing point again being point number 1. We'll average our multiple angles. We don't have any, so it doesn't matter. Vertical error. Again, we only have flat measurements. And it's okay, 1 to 5. And now the angle is 4 to 5. Okay, so now back to our original before angle balance closure of 1 and 20,991. Perform our angle balance, which drops our closure precision just a little bit because we've got apparently more contribution of error from the distance. And then we will do the compass rule adjustment. And here you can see now the adjusted coordinates. See the original coordinates. And now these adjusted coordinates, you see they're, at least in the northing, they're exactly nominal. A little bit off in the easting, and only one of which, this one, would not round up to be those nominal numbers. Okay. But that's where it's applied them. And once we're through with that, then we could save the raw file if we'd made any edits to it, and save the coordinate file. And then we could close this. Just exit. The processor. And there's now my points. So 5,000, 5,000, 49, 49, 5,000, 5,000 right there. Would round up to 5,100. That would be 99.99. That might go to 5,000.01 depending on the rules. Okay, so you can see how it has adjusted those. Now, a couple other quick things with that. If you edit and process that, let's go back to that and open this raw file 2. And you may notice that it is considerably different than that little file. This one's an actual real file. Okay. So what are these records up here? These are DS records, description records. And these are things that are just stored from the data collector. You can see that I'm using feet as my units. Angles are in degrees. Azimuth is reference to north. I'm using zenith angles for the measurement. This is 0. So those are angles measured down from the zenith as positive. So 90 degrees will be flat out in front of me instead of 0. All right, so these are, again, all of these things that are stored in the data collector. There's an Icon DTM 350 as my instrument. And I have my tilt correction for vertical angle and horizontal angle are both applied. Job number 1698. That's when it was created, 7th of July, 2006. I had 2 store point numbers, 5,000, 5001. As point numbers, so 0.5000 is 5,000, 5,000, and 5001 is 5,045, 05.78. So if you click a given item, in this case, point number 5,000, notice it turned yellow down here in my graphics screen. 5001 looks like it's right there. It is. Okay, now, another thing that can help you, if you look up here, as I scroll down, you can see quite a lot of records. Okay, and there's all these side shots that we don't see. If you really turn that on. So let's say you're looking at this and you're analyzing where maybe something might have gone wrong. Maybe there was a, you wanted to find this closing observation here. Where is it up here? Now you can scroll through it and try to find it, but if you simply click, it will jump to the record that is being set. So that is sitting on point number 5001, which is right here. And it observes 5002. So that's actually a traverse that starts and runs counterclockwise. So really, there's your, in fact, it says closing angle, angle balance. So 5005 to 7001. Shows up for us there. Now, I did not see my 5,000. Oh, 5001 is actually 7001. So this 7001, oh, right there it says equals 5001. Okay, so there's my closing deal. But I've also got this point 5000. I've got this point 5001. Those are my stored points. Now, at 5000, I also established this point 3190, 3186, 87, 89, and 90. So all that really did was establish this little sub-traverse over here. Doesn't connect to this part of my traverse as well. Same thing with this one. If I select that and look up here, I am at 5001 and I'm setting 5006. And again, it's setting a traverse point, but it doesn't go anywhere from there. Just establishes a single traverse station, moves up and occupies it. It does it so that you can then establish some side shots from that point. Now, we don't see those side shots yet, but if you want to, this button right here, show the side shots, click, turn it on, and there they are. There's quite a few of them. Okay. So I'll turn those off. And now how would we adjust this in terms of processing it? Well, again, let's go and look at the raw closure with no adjust. And our reference that was 5001 equals 7001. So the reference closing point is 5001. That's what it should be. Okay, so 5001, it comes all the way around to 7001. That's correct. I'll say okay. Now, so I've got a closure of 139,000, one part in 139,000. And any of you older school surveyors know that, what are our typical local ordinances? They're going to require like 1 in 25,000. So probably not bad. But, and you can see, there's my northing. So, half a hundredth. And this is like half of a thousandth. So there's really very little error, but and a lot of people are quite often satisfied with this and they just let it go and you're working on raw coordinates. However, that's reporting the side shots. All right, so I'm going to go back to now do an angle balance. I'll turn the side shots off. That closing point was 5,001. As a reference. And this is 5,002. No idea what it's supposed to be. Oh, shoot. I've always looked at this thing backwards. Sorry, I'm going counterclockwise. It's 5,005 to 5,001. The measured closing point. Wow, I should not have that much error. All right, let me try this again. Angle balance. All right, reference closing is 5,001. So I start at 5,001. 2, 3, 4, 5, 7. See what it says. Yep, that's exactly what it needs to be. It's gonna be, that's my closing angle. Let's see, 5,001. Okay. Here's an idea. I've got some invalid rod heights. I think we'll leave those. Probably they were set down low for a direct reading, maybe a reflectorless shot. All right. 866, 78, 78. 5,000, 5,000. Okay, so that's all. Well and good. See, I don't know what the I don't know what that reference is supposed to be. Let me leave that angle balance alone for a minute. 1001. Apply. So, okay. Yeah, see, something fundamentally wrong with that. Let's see, after the angle balance. All right, let's see. See, 7,001 doesn't exist yet. Okay. And if I reference this to that, oh, it just doesn't make any sense. Let me see. Bad angle at 5,001, setting 5,002. All right, there's something definitely amiss. 5,001 sets to 5,002. 5,001. Let's see here. All right, we stored 5,000, we stored 5,001. Now 5,001 is setting 5,002. Up here, 5,001 is looking at 5,000. 0 to plates. Instrument height, rod height. Side shot, it set these 4 side shots and then traversed up to 5,002. That part's fine. Now, why did he go back to this? So he went back to 5,001, looking at 5,000, and he sets, oh, look right here, 5,001. To, oh, sorry, 3,001. Then he picks up and goes to 5,002, back sights 5,001. New rod height, sets all of these side shots. A new rod height, sets another side shot. All right, HT changed at PT was 3,009. Old height was 495. Okay. Just a comment, a description note there. So 0.35. No idea. All right, it's just for a side shot anyway. All right, so then 5,002 sets 5,003. And that backside is 5,002 to 1, sets to 3. This one is 5,001 looking at 5,000, sets to 2. Well, I do not see exactly why or how. So if he sets 5,003 here. Now 5,003 then sets 5,004. 5,003 looking at 5,002. Okay. This is 5,004 looks at 5,003 and 4 to 5. So 4 now looks at 3. 5 looks at 4. That has no that is no functional use whatsoever, that record right there. Why did he pick up? So 5,005 looking at 4. I guess maybe just to get the different HI. All right, so he's 5 looking at 4. Then he sets that point right there, and that is a closing distance and angle balance shot. 5,001 looking at 5. Ah, no. It just sets that. Well, I don't want to waste all your time here. I don't know what's going on with that. It's just, I've not seen that process that way before on the older versions of the software, so I don't know. Let me get a direct reverse report. If those are just outside of my warnings, that's fine. We're not doing direction reverse anyway. Well, it just does not make sense. Measured closing is missing. Well, 5.1, okay, and then the azimuth is there. It's showing this measured closing bearing of north 1226.55. That's this line 05 to 01. But that should not be its angular error. See, that would be, what is that supposed to be? Something. Yeah, see, that number right there is something I need to know, which I don't know what that would be without calculating it. Let's see. If I run this. All right, so the azimuth of the arrow it doesn't give me there's 1, 2, 3, 4, 5. Those interior angles should be 540 degrees. All right, maybe it should be 5,000. I wonder if that doesn't do it. I don't think so. Let's try it one more time here. All right. Now, yeah, see, I would have to know what that angle is. So 5,005 to, excuse me, 5,001. That should be see, but I don't. Well, excuse me, I will try to research that a little tonight. And let you know tomorrow when I move off of this. So if we, I know we're going to be trying to come back to this. There's a 0578, 60.86. 0578, 60.86. That's what it's trying to be. From 5,001 to 7,001. All right, so the measured points, there's my measured azimuth. I need the reference closing angle. I have no idea. It should be 5,005 to 5,001. Except it's an angle, not. That's what I measure. I have to figure out, or I would have to know what it is I'm expecting to hit for it to be able to do that. And of course, I'm not going to be able to tell I start at that point, I go back into itself. 5 to 7,000. There's no adjust, that's just the raw computation. Gives me this. Now, if I don't do an angle balance, if I just do a compass rule, I'll uncheck that. So 5,001. So there's the raw. Checkpoint, which looks good. Adjusted elevation comparisons all look good. Compass closure. That's a really nice adjustment amount. Maximum adjustment 5,000. 5,000 to 5,001, back to 5,000. 5,001, 7,000. Okay, so adjusted the elevations. Here's my compass closure adjustment. Original adjustment, that amount. So but I should be able to do an angle balance. Let's see, would I be able to, if I'm if I'm sitting here, my backlight is, I'm sitting here looking at 5,000. So I turn into that line. Then I turn that angle, that angle, that angle, that angle. Oh yeah, see, I can't because I never get back to this line, that original backlight. Is that correct? So if I set that line, I've got this angle, 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 and this is never observed right here. does it need to be? Um, I could calculate that. I'll do that offline and let you know what it does. So in any case, that is what you would find out, and you want to, as you see those reports, excuse me, you would, uh, get a sense of whether you've got any kind of busted measurements. Everything looks good. You've got really good closures out of that data. And excuse me, pardon me. So you got good closures out of the data. So that part is reassuring. Again, it's actual data. So these traverse points get adjusted, and these side shots then are computed from the adjusted coordinates. And if we see that, let's see. 1001. Side shots, point adjustments. So normally, all right, so if we look at this point 3010, it has 48, 19, 43, 52. We just copy that. So 3010. Let's go back up to the unadjusted for comparison's sake. If I can get to it. Thirty, 10. There you can see. So it has indeed adjusted the side shots based on the adjustment to the traverse points. See the different results here. But when it processed, it did not, for instance, it did not spread the angular error out among all the side shots. All it did was adjust the traverse lines, and then the side shots as single observations are just simply computed raw from those positions. Okay. This is no adjust. See anything. Well, it's exactly exactly what I would think it should be. However, the angle balance. Okay. Right here, the process method applies an angle balance to the lines. Okay, angular error divided by the number of traverse lines. But that angular error measured points is 8 to 9. Bearing. See, this is a number, that angle, we'd have to know what that is expected to be. It's not going to pick it up. Can't compute it from the point numbers, but it should be able to calculate that. The difference between the angle balance shot and the reference angle. The reference angle specifies a bearing and azimuth or by 2 point numbers. That should go from 5,005 to 5,001. All right. One last pass through that and see. Oh crap, that was side shuts again, sorry. Yeah, see, it's still doesn't calculate. Well, all right. We will close that, save our coordinate file. And let's look at, just to show you the different complexity here. Let's look at this North Line 6 as the next file when it comes up, and you can see this one has multiple traverse loops. You see this loop here. I've got a, not quite a loop up here that really kind of goes out and just ties that together. Well, I've got a loop here, a loop here, a loop here, and a loop here. So that is your multiple network traverse file. And you could certainly when we show all the side shots, you can see everything that was picked up from this traversing. Okay. So this is one that would typically, however, be set up and processed with a least squares processing arrangement. So if we take a look at that, I'm not sure if I've got, let's go to survey, ServNet least squares. And if I have the right defaults in place, apparently it looks like it did. See what it comes out to be. All right, so it converts to a solution. What do we have? I've got some warnings where I exceeded my tolerances. Let's see. Draw this network. It's going to actually draw within my drawing file, and it's going to compute the adjustment whereby the errors at each point are excuse me, are minimized as each of those network loops are connected to the other. So it's going to take to draw this one. Did any of you try this? Did you load this file up and run through drawing this network?
Yeah, I'm having trouble with it. It doesn't seem to want to telling me it can't, file not found.
All right, so let me see if I can cancel this or let me let it continue. Let me stop my screen share. Do you know how to share your screen?
Yeah, hang on. Let me put my, if I'm using multiple monitors, do I need to put
Yeah, will you?
Carlson on the laptop?
No. In fact, I've got mine on an external monitor. If you just share a screen, then you'll pick from the list that'll show you which ones are which.
Okay.
There we go. All right, now. So let's see if I need to,
So if I click here and then try to adjust, I'm just getting an error message.
all right, so close that for a minute. All right, so now, let's- let's see where I'm supposed to be able to request. All right. But what we have to do is in this setup first. So if you, so if you, you go into the settings, I don't understand this. Not letting me. Request. All right, well, yeah, it's not doing it. Okay. Well, regardless. All right. If you if you look at this gear icon,
Yeah.
yeah. So if you choose that, and then you would look at the input files tab at the top, and right in there now is where you would excuse me. Gosh, I'm sorry. Let's see. Those are our files there. Look at the pre-processing. And okay, try the adjustments. It's okay. Output options. There's if you want to export to a coordinate file, if you adjust it, you would turn it on. So that part's okay. Back to the input files a minute. That should be, that's where they used to put these. Let's see. Let's use units. All right, look at the global settings down here at the bottom. Nope. All right, cancel that. Now close that and close or go, choose the exit button, the one that looks like going out the door, lower right icon. Two over. Yeah, you were almost there. Good. It looks like there, right there.
Yeah.
Okay. No save. Discard's fine. Yeah, discard. Now run the command again. And up. So certain at least squares. Now right here, select a new folder location. Yes. And when you do that, that's what you want. That's, yes, right there. Choose that and then choose open. Now you should be able to.
Oh, there it goes. All right, we got it.
Now what I want to see is how fast when it, if you click the pencil, the red pencil on the bottom row. Yeah, so yours drew really quickly. Mine has something wrong with my processing. All right, so there it is now. If you keep zooming in, let's see, right in there. See those error ellipses, those ovals?
Yep.
Those ovals are the region in which the point, each of those points has one. So those points will fall within that region with a 95% confidence level, or whatever confidence level you set up in the controls, and it's typically 95%. Now, here's something that you can tell from those error ellipses is the orientation and the shape. Well, these are drawn scaled.
Okay. Just curious what the error, how much error it's giving it, or how much.
And, well, you'd have to go to the adjustment report and look at point number 44, and it'll tell you those numbers. But the orientation and the relative size of those ellipses show you where the, see, zoom into, say, 163 there a little bit, get it, yeah, like, and put it sort of centered. All right, now, so get a sense of how that oval is rotated up about 50, I don't know, 30 degrees off the horizontal. Now scroll back out a little bit so you can see more of the network. So, right, yeah, keep going a little bit more. All right, so what? So this observation coming from the left into that point and the observation coming from the right into that point, one or both of those lines created that point. Those observations created that point. Now, it could be that, say, this point over here was created from here, so maybe there's only one thing that sets it. But everything that conspires to compute that point gets calculated, and the adjustment is made so that that ellipse of error is minimized. But if you look at the on a very simple case, if you zoom out, and let's say we looked at, say, let's look at this first point in that sort of the back of the, this first little loop on the left. It looks like a sock. Yeah, look at that point back there at the back of the heel, right there. Yeah, so if you were to look at that, okay, so there you can see that ellipse. Now, it's saying that there's a greater proportion of error along this long axis than there is along the short axis. That means that maybe the angle that set that point, if you were to swing this line, well, the angle, would go close to straight up and down, so it would be a pretty short, okay? If you were to swing the other line coming in from the bottom, to sort of set that angle. It's still closing in on that short dimension, the short axis of the ellipse. But the, but the distance also has a component of that. So I'm having a hard time articulating what it is what these are supposed to tell you. They'll give you a sense of, where, like if what would really be useful. Let's see, so take a minute. Yeah, see, there's something wrong with my graphics, I think. I'm still drawing over there on mine, but when you draw those, it's the orientation and the relative size. Like sometimes these air ellipses will be nearly circular, which means that you've got nearly the same contribution of error from something that sets the angle that point, as well as the distance. But if you get
So
something
there's more error this way
correct,
and less error that way.
that is correct. Now, what that means is, or how they can help you, if it is something you need to worry about, is you could see, in this case, there's not really anything that jumps out at me, but if it were really severe one way, and if it were lined up, say, instead of being at that 45-degree angle, let's say it was lined up parallel to that line that's going, sort of horizontally across,
Mm-hmm.
that would tell me that that particular set of errors is very sensitive to that distance measurement. And, so it slides, it holds it up and down. It holds it at the right latitude, but it's the longitude that it's moving rather quickly based on multiple observations. And this only comes about when, let's say that from point 35 to 34, or in this case, 34 to 35 probably, would really be observed multiple times. So however many times it computes that, it's only going to draw us one connecting line between 34 and 35, but that might represent 8, 10, 12, 16 different measurements. And it's as those measurements vary, what causes that to indicate that angle. So
what that ellipse at 35 is telling us that this is more of an angular.
that's exactly right. That one shows that
we're turning from here to here,
correct.
and this angle.
Yep, it's more sensitive that way. It's given more fluctuation in that direction or along that axis than it did the distance. But you can see there is some contribution from the distance as well as from the angle.
Yeah.
Now, you got to combine that with, if you scroll back out a little bit, point number 33 was computed by probably 32. So all of these things are having this cascading effect. And then if you get down, if you keep tracing around, go ahead and zoom back out till you get back around to where it ties back into something else. If you keep coming around, yeah, down in there, right? So 44 gets set from 43 sets 44, which sets 45 probably. Now, does 44 set 163, or did 163 observe 44? So that could have some kind of double impact in that particular case. So, but that's the rigor of doing this adjustment through a networked least squares adjustment, is you don't really, it self-recognizes all of those observations and makes the adjustments as it knows those dependencies. And it's also, it doesn't care whether you're measuring a distance or an angle, or Sometimes you'll measure a distance and an angle. Sometimes all you've observed are angles. Sometimes, so you could have a trilateration network or a triangulation network. You could go out there and measure, say, 44 to 163 with a distance meter. You could measure, 100 different measurements there to get a really precise distance component on that, but only measure it once with a hand compass as far as an angle goes. And it will take all of that into account in the adjustment. Now, you'd have to give it a relative weight when you measure something with a hand compass. And sometimes it's just, I won't say guesswork, but you have to know a bit about the equipment to make these setups and all of that. So that is sort of the assessments of doing these. And if you are using a lot of traversing to get your points in the office, then it's really this one. And there's nothing wrong with using this, by the way, to calculate those little bitty sample traverses that we looked at here earlier. You can still do those with least squares adjustments. I just don't have the setup files created for that yet. If I did, then I could let me see if I can turn this thing off. Probably time for those guys to get their sales quotas up for extending your car's warranty, which I don't even know my car. It's in release. But anyway, so, in fact, a lot of guys this is the only type of adjustment that they'll ever use. So there's nothing wrong with doing it as a traverse adjustment on those little ones. It's just that the results of doing it with least squares and with compass rule are exactly the same, because the weighting, the least squares weighting at WEIGHTING, not like biding your time waiting, but the amount of weight that you give to the measurements. If they're all equally the same, then they become what's called unit weighting. And then that's all of those complicated squares terms will fall out of the equations because they'll cancel each other out on either side of the equal mark. And it leaves you with the basic equations for the compass rule adjustment. So again, it's not a bad option just to, you get everything set up, and I'll show you as soon as I can get. I'm gonna have to kill mine. All right, and in that task. Yeah, we'll bring this back to this. So we'll call this one. So. And it's off, turn it back on. And let's see. So that was our, it's looking for a project file. So I don't have a project file created from that raw file yet. So if I make a new one, just call this one test. Now let's see what I can do. I'm not sure if it's going to set up some defaults or not. If I take a raw file and I add that raw file to, okay, that's the one we had earlier. Now notice when we add these files, I've got raw files, those are my traversing files. I've got GPS vector files, I've got level files, and I've got control files. You see these different ones that I could add to this. So it ties all of those observations together. But the key is you would produce your settings or set up in your settings that you would have I think these are all fine. Let's see if it'll work. Yeah, it's got these things set up, standard errors. So I've got a distant standard error. I've got a constant error of a hundredth, 5 parts per million, a pointing error, and a reading error in seconds, 3 seconds there. So, okay, so this should be side shots for relative ellipses. Uh, all right, let's see. Let's see. Now, if we do the adjustment, up, I have no horizontal adjustment performed, only side shots reduced. Well, that didn't make sense. Oh, it does make sense. I did not have any adjustment whatsoever. Let me see if this might fix that problem. Okay. Vibration. Well, I don't have enough redundancy on there to be able to do it. But if oops, so it does the processing very quickly enough. And now I should be able to draw. Yeah, so you remember how yours was nearly instantaneous, Mark?
Yep.
I mean, not instant, but certainly more so. And look at mine is just starting to creep into it.
Mhm.
That's because of two things. One, running through Windows emulation, and two, running across, doing this while hosting a Zoom session. So Zoom is trying to cut this down as well. So anyway, let's move on ahead. See if I can get this to cancel without killing the process. All right. All right. Let's move beyond that. And, so there you have a little deeper than we want it to be. Look at that raw file processing. And here's our level file processing that is also on that same menu. And this is simply like it's exactly like your typical leveling field names. See, it says right there, the editor replicates typical field data for level data. And it just does your standard adjustments, does page checks for you. But these are just where you read just a single one. If you want to use 3-wire differential leveling, and if you've got multiple level loops and networks that are cross correlated, then that needs to be done in the least squares processing. We'll take this presentation here as well. All right. So let's see. A little more CertNet. These were from the old system. It did not have that side panel like you see now. And here's your relative error ellipses, a bunch of points. You see here, some are more oval, some are rounder. In fact, you can see that's this little same process that we've got, okay? So now, with let's put a bookmark here prior to field to finish. Actually, I think what we'll do, I'm going to save that for tomorrow. I'm going to skip ahead here to page 71, and we're going to look at the deprocessing, so you can get a little bit of a breakout of the technical stuff and get more into what a lot of you will do for boundary work. And it will be a little bit easier to wind out today. So let's go ahead and take our mid-afternoon break. We'll go ahead and come back, say at 3:20. Maybe a chance to stretch your legs, get some coffee, wake yourself up, and we'll finish out the day after having done some bead work, and then we'll come back tomorrow with field to finish, and we're going to hit that pretty heavily because again, it's pretty work with. All right, so any questions to this point? And I apologize for the disjointedness of all of that journey, but I don't know what's going on with my settings. There's no questions. I'll see everybody back here at 3:20.
Okay.